Let us start with today's lecture. We are going to continue with chapter number 15, which is kinetics of a particle, impulse and momentum methods. And we are going to continue with, first of all, one of the exercise problems from central impact, जो कि last time हमसे रह गया था, and then we are going to discuss the phenomena of oblique impact and the procedure for analysis of oblique impact problems. So starting with central impact, as you already know that for any problem of central impact, there are essentially two steps for solving those problems. The first one is step number one में आप क्या करते हैं? You are going to apply the conservation of momentum principle on that system along the line of impact. So summation MVI should be equal to summation MVF. And in the second step, for any problem involving central impact, you are going to apply the coefficient of restitution equation. Now, these two equations would give you a relationship in terms of final velocities of the two particles, VA2 and VB2. So solving these two equations simultaneously will give you the value of those two unknown quantities. So last time we did solve some examples and problems relevant to this topic. Today we are going to solve just one problem from the exercise, and then we will move forward to oblique impact. Now in this problem, which is problem 15-59, you have a particle which is this ball A having a mass of 2 kg, and it is thrown towards this block B with a horizontal velocity of 4 meters per second. The coefficient of restitution between these two particles is given to you as 0.8. You need to determine the maximum height h to which this block will swing before it momentarily stops. So इस collision के नतीजे में block B is going to get some momentum. What should be the maximum height attained by this block after this collision? You have to find out that maximum height h. So first of all, is it a case of central impact or oblique impact?
Sir, from the figure it is central.
So from the figure it is clear that this is a case of central impact. So this is going to be the line of impact, which is the x-axis here, and this is going to be the plane of contact. So आपके पास y-axis आ जाएगी. Although as far as this central impact is concerned, you don't require that plane of contact. उसकी ज़रूरत आपको पड़ेगी once we are discussing the oblique impact problem. So since after joining the mass centers of these two colliding particles, the velocity of particle A before collision is along the line of impact, while particle B was at rest. So this is a case of central impact. So once we have recognized that it is a case of central impact, applying step number one on this problem, that is the initial momentum of the system along the line of impact should be equal to the final momentum. So as far as the momentum of this ball is concerned, it is going to be 2 multiplied by 4, where 2 is the mass of this ball and 4 is the velocity of this ball. The momentum of block B, what is the momentum of block B?
Momentum 0.
Since block B was at rest before collision, so it would have 0 momentum, and that should be equal to the final momentum, which is 2 VA2 plus 20 VB2. So you are going to get one equation in terms of VA2 and VB2 in step number 1. Okay, for step number 2, what we are going to do is we are going to apply the coefficient of restitution equation along the line of impact. The value for this coefficient of restitution is already given to us as 0.8, and by formula this coefficient of restitution would be equal to VB2 minus VA2 divided by VA1, which is 4, minus VB1, which is 0. So this will give us the second equation in terms of VA2 and VB2. So once we solve these two equations simultaneously, they will give us the value of VA2 to be equal to minus 2.54 meter per second, whereas the value of VB2 comes out to be 0.655 meters per second. The negative sign of VA2 represents के collide होने के बाद block A is going to move towards the left, while the positive sign of VB2 represents के collision के बाद this block B is going to move towards the right with a velocity of 0.655 meters per second. So these are the two steps which you will be requiring. for finding the magnitude of these final velocities. Now, once this block B has got this much of momentum due to this velocity 0.655 meters per second, now how you are going to find out the maximum height attained by this block B? What principle should you apply here?
Conservation of energy.
So you are going to apply the conservation of energy principle on block B from position 2, which is just after impact, to position 3, which is the position of maximum swing, जिस पे ये height h आपने find करनी है. So applying the conservation of momentum principle on this block between position 2 and position 3, which says that T2 plus B2 should be equal to T3 plus V3. The velocity, the kinetic energy is given to you as half mv square. So it is going to be half 20 into 0.655 square. Let's suppose that we are defining the datum at position 2. So if the datum is being defined at position 2, what is the gravitational potential at datum?
0.
0. What about T3?
0.
The since T3 represents the kinetic energy of this particle at position 3, which is the position of maximum swing. So once the block has attained maximum height, it means that the velocity is going to be 0 at that maximum height. Therefore, T3 should be equal to 0. What about V3? Should it be positive or negative?
Positive, sir, above the datum.
Since position 3 lies above the selected datum, so it should have positive gravitational potential, and the value is going to be W times H. So from this equation, the only unknown quantity is H. So once you solve it, the value of H comes out to be 0.0218 meters. So this is going to be the height attained by this block B as a result of this collision. At position 3, the block would be momentarily at rest, and then it is going to swing back again. Any query regarding this central impact problem?
No, sir.
Okay, so I hope central impact is clear to all of you.
Yes, sir.
Okay, now moving on to oblique impact. Now, as we have discussed earlier as well, oblique impact कब होता है? Whenever the two colliding particles, if either one or both of them are traveling at some angle with respect to the line of impact, then that particular type of impact is termed as oblique impact. So when oblique impact occurs, both these particles move away from each other with velocities having unknown directions as well as unknown magnitude. So overall, the number of unknowns involved in case of oblique impact are 4. It means that in order to solve for these 4 unknowns, we would be requiring 4 equations. The unknowns here are going to be the magnitude of these velocities VA2 and VB2, as well as the direction of these velocities theta2 and phi2. So from where we are going to get these 4 equations, let us consider the case of oblique impact of 2 particles as shown to you in the figure. We have 2 particles A and B. Initially, particle A have a velocity of VA1 and it was traveling at an angle of theta1 with respect to the line of impact. Similarly, particle B having a velocity of VB1 at an angle of phi1 is traveling as shown to you in the figure. Once collision occurs, then joining the mass center of these 2 colliding particles will give you the line of impact to be this line, which is in this case to be the x-axis, and perpendicular to that line of impact we define another axis, which is the plane of contact, which again fortunately here is the y-axis. So not necessarily हमेशा ये नहीं होगा कि x और y-axis ही आएंगी. It depends upon the collision. कि collision किस तरह हो रही है, उसकी basis पे you can define कि आपकी line of impact कहाँ आ रही है और उस line के perpendicular आपका plane of contact आ रहा है. यहाँ सिर्फ समझाने की हद तक आपको जो 2 lines दिखाई गई हैं, line of impact is basically along the x-axis and the plane of contact is basically along the y-axis. So after collision, these particles are going to travel with velocities VA2 and VB2 at an angle of theta2 and phi2 as shown to you in the figure. So the unknown quantities here are the magnitudes VA2 and VB2 as well as the directions theta2 and phi2. So in order to solve for these unknowns, we are going to have 4 equations. From where these 4 equations are going to arrive? In step number 1, what you are going to do is, पहले स्टेप में आप क्या करेंगे, you are going to apply the conservation of momentum principle along the line of impact on the system of particle. जिस तरह central impact में आप करते थे, in case of oblique impact as well, all the deformation as well as restitution impulse is going to act along the line of impact. So since there is no external impulsive force acting along the line of impact, it means that the system's momentum has been conserved along the line of impact. So applying the conservation of momentum principle along the line of impact, the equation would become ma VAX1 plus MAVX1 plus MBVBX1 should be equal to MAVAX2 plus MBVBX2. So step number 1 is almost similar to the step number 1 of central impact. The only difference here is, in case of central impact, the momentum was totally along the line of impact before collision. So after collision, the momentum is again along the line of impact. However, in case of oblique impact, you are only going to include the components of momentum which are along the line of impact. For example, this is the initial momentum MAVX1. So in other words, you are going to resolve the velocity and take only those components of velocity which is along the line of impact. So MAVX1 is the component of initial momentum of particle A along the line of impact. Similarly, MBVBX1 is the component of initial momentum of velocity B or particle B along the line of impact. Similarly, these are the components of particle A and B final momentum along the line of impact. So difference कहाँ है step number 1 का from the step number 1 of central impact is कि आपने बजाय कंप्लीट मोमेंटम कंसीडर करने के आपने मोमेंटम के वो कंपोनेंट्स लेने हैं जो कि लाइन ऑफ इंपैक्ट के अलोंग हो. इज दिस पॉइंट क्लियर टू ऑल ऑफ यू? जी क्लियर है ये पॉइंट?
सर लाइन ऑफ जो इम्पैक्ट है किसी एक बॉडी के अलाउंग ले नहीं सकते किसी के, क्योंकि उसका एक कंपोनेंट रिड्यूस हो जाएगा.
नहीं, देखें लाइन ऑफ इम्पैक्ट डिफाइन आप किस तरह करें. लाइन ऑफ इम्पैक्ट इज बीइंग डिफाइंड टू बी एन एक्सिस which can be obtained by joining the mass centers of the two colliding particle at the time of impact. ठीक है, सो लाइन ऑफ इम्पैक्ट आप चेंज नहीं कर सकते. वो देखिए फॉर्चुनेटली मैंने यहाँ कहा कि एक्स एक्सिस बन रहे हैं, हर दफा वो एक्स एक्सिस नहीं बनेगी. मसलन आपसे मैं कहता हूँ कि आपके पास एक पार्टिकल है जो कि ट्रेवल कर रहा है. सपोज हम वो बॉल की एग्जांपल ले लें कि मैं आपसे कहता हूँ एक बॉल है जो कि ट्रेवल कर रही है इन दिस डायरेक्शन. तो अब आपके पास ये केस जो है वो ऑब्लिक इम्पैक्ट का बन जाता है. तो आप लाइन ऑफ इम्पैक्ट जो है उसको चेंज नहीं कर सकते. ये आपकी लाइन ऑफ इम्पैक्ट है सिंस दिस पार्टिकल वाज ट्रेवलिंग एट सम एंगल विद रिस्पेक्ट टू द लाइन ऑफ इम्पैक्ट. सो लाइन ऑफ इम्पैक्ट आप चेंज नहीं कर सकते हैं. यू हैव टू हैव द सेम लाइन which can be obtained by joining the mass centers of the two colliding particles at the time of impact. ठीक है?
Okay, thank you.
Okay, so step number 1 में आपने लाइन ऑफ इम्पैक्ट के अलोंग कंजर्वेशन ऑफ मोमेंटम अप्लाई कर लिया. सो आपके पास ये इक्वेशन नंबर 1 आ जाएगी in terms of the x components or the components of momentum of these two particles along the line of impact. Okay, step number 2 में आप क्या करेंगे कि आप इसी सिस्टम के ऊपर coefficient of restitution की इक्वेशन अप्लाई कर देंगे along the line of impact. So that coefficient of restitution is going to be E equal to VBX2 minus VAX2 divided by VAX1 minus VBX1. So again, step number 2 is similar to the step number 2 of central impact. The only difference is कि complete velocities लेने के बजाय you are going to consider only those components of velocities which are along the line of impact before collision and after collision. So once you solve these two equations, you can find the value of these unknowns VAX2 as well as VBX2. So the x component of momentum can be determined by solving these two equations simultaneously. यहाँ तक clear है रेक को? ये दो वही steps हैं जो हम central impact में कर रहे थे. The only difference is instead of considering the whole momentum or velocity, we are going to consider the components of momentum or velocity along the line of impact before and after collision. Is this point clear to all of you?
Yes, sir.
Okay, now moving on to the third step for problems involving oblique impact. In step number 3, instead of applying the momentum impulse method on the system, we are going to first of all consider particle A. Can you tell me, is there any external impulse acting on particle A along the plane of contact?
So the impulse.
मैं दोबारा रिपीट कर देता हूँ. Is there any external impulse acting on particle A, or external छोड़ दें, is there any impulse acting on particle A along the plane of contact during this collision?
So the impact of B.
The impact of B, which is either in case of deformation impulse or the restitution impulse, it is acting along the line of impact. So if it is acting along the line of impact, is there any other impulse which is acting along the plane of contact, the y-axis?
So the impact of B component.
देखिए वही तो मैं बात कर रहा हूँ कि जितना भी बी का इंपल्स आएगा वो बेशक वो रेस्टिट्यूशन इंपल्स की फॉर्म में हो या वो डिफॉर्मेशन इंपल्स की फॉर्म में हो, द डिफॉर्मेशन एंड रेस्टिट्यूशन इंपल्स ऑलवेज एक्ट्स अलोंग द लाइन ऑफ इम्पैक्ट. सो इफ देयर इज एन इंपल्स व्हिच इज एक्टिंग अलोंग द लाइन ऑफ इम्पैक्ट एक्स एक्सिस के अलोंग, वाई एक्सिस के अलोंग उसका कंपोनेंट क्या होगा? 0 होगा. सो सिंस देयर इज नो इंपल्स acting on particle A along the plane of contact. So if there is no impulse acting along particle A or along the plane of contact, should there be any change of momentum on particle A along the plane of contact? जब कोई impulse ही act नहीं करे तो क्या कोई change आएगा y direction में?
No, sir.
So since there is no impulse acting on particle A along the y-axis, all the impulses acting along the line of impact, which is along the x-axis. So it means that whatever momentum of particle A is before collision along y-axis, it would remain to be same. That is MA VA-Y1 should be equal to MA VA-Y2. Similarly, in step number 4, you are going to apply the same logic to particle B. Since there is no impulse acting on particle B along the plane of contact, so there shouldn't be any change in particle B's momentum along the plane of contact. Therefore, you can write MB VB-Y1 should be equal to MB VB-Y2. So from these two equations, you can find out the values of VA-Y2 as well as VB-Y2. So all the four unknowns are now known to you. Now you can find out VA2, which is equal to VAX2 square plus VAY2 square whole under root. Similarly, you can find VB2 to be equal to VBX2 square plus VBY2 square whole under root. इससे आपको इन दोनों फाइनल वेलोसिटीज के मैग्नीट्यूड मिल जाएंगे. जहां तक ताल्लुक θ2 और φ2 का है, कैन यू डिटरमिन नाउ θ2 एंड φ2? जी θ2 और φ2 कैसे आप फाइंड कर सकते हैं? एनी आइडिया? आवाज आ रही है मेरी?
स्क्रीन से रिपीट कर देंगे प्लीज.
जी मैं पूछ रहा हूँ कि थीटा, देखें आपने ये चारों के मैग्नीट्यूड तो फाइंड कर लिए, VAX2, VBX2, VAY2, VBY2, जिससे आपको VA2 भी मिल जाएगा और VB2 भी मिल जाएगा. बाय आपको दो कंपोनेंट्स मिल गए वेलोसिटी के, उनको स्क्वायर करके सम करके अंडर रूट करेंगे, आपको VA2 और VB2 की वैल्यू मिल गई. मेरा नेक्स्ट क्वेश्चन है, हाउ यू आर गोइंग टू डिटरमिन θ2 एंड φ2? Abdullah Liaquat, is my voice audible?
यस सर।
तो क्या चक्कर है,
Yes,
सारे
sir.
बिल्कुल खामोश हैं।
Theta 1 plus theta.
सर एक्स वर्क कंपोनेंट अगर हमने फाइंड कर लिया तो फिर टेंजेंट से फाइंड करना
सिंपल
है।
टेंजेंट से हम थीटा 2 और फाई 2 फाइंड कर सकते हैं। तो थीटा 2 इज गोइंग टू बी tan इनवर्स va/y2 ओवर va(x2), इसी तरह फाई 2 इज गोइंग टू बी tan इनवर्स vb/y2 ओवर vb(x2). ठीक है, क्लियर है ये? सो दीज आर द 4 स्टेप्स जिसको हम अगर समराइज करना चाहें, सो व्हेनेवर यू आर गोइंग टू सॉल्व एनी प्रॉब्लम relevant to oblique impact, it is going to be solved in 4 steps. The very first step is you are going to apply the conservation of momentum principle on the system along the line of impact, from where you are going to get one equation in terms of final velocities along the line of impact. Then in step number 2, you are going to apply the coefficient of restitution equation along the line of impact. Both these steps are going to be applied on the system. इनको आप सॉल्व करेंगे तो यू आर गोइंग टू गेट द अननोन वेलोसिटीज va(x2) एंड vb(x2). स्टेप नंबर 3 में आप इंडिविजुअल पार्टिकल ए और स्टेप नंबर 4 में इंडिविजुअल पार्टिकल बी के ऊपर प्रिंसिपल ऑफ इंपल्स एंड मोमेंटम अप्लाई करेंगे। क्योंकि प्लेन ऑफ कॉन्टैक्ट के अलोंग किसी किस्म की कोई इंपल्स एक्ट नहीं कर रही, सो द मोमेंटम ऑफ दीज पार्टिकल्स अलोंग द प्लेन ऑफ कॉन्टैक्ट would remain same. That is, va(y2) should be equal to va(y1). Similarly, vb(y2) should be equal to vb(y1). In this way, you are going to determine the 4 unknowns involved here. Once you have found those 4 unknowns, you can find out va2, vb2, theta 2 and phi 2. Is the procedure clear to all of you?
यस सर। सर अगर आप जरा दोबारा ये समझा दें कि ये प्लेन ऑफ इम्पैक्ट के अलोंग कोई फोर्स इम्पैक्ट एक्ट नहीं करती, बेहतर समझा जाएगा दोबारा।
अच्छा चलें, मैं दोबारा रिपीट कर देता हूँ। देखें, ये वो इनिशियल फिगर थी ऑब्लिक इम्पैक्ट की जो हर एक को विजिबल है, आई होप।
सर
ओके, होता क्या है ड्यूरिंग इम्पैक्ट, बेशक वो सेंट्रल इम्पैक्ट हो या वो ऑब्लिक इम्पैक्ट हो, जितना भी इम्पल्स एक्ट होता है, बेशक वो डिफॉर्मेशन इम्पल्स कह लें या रेस्टिट्यूशन इम्पल्स कर लें, ये दोनों इम्पल्सेस एक्ट होते हैं अलोंग द लाइन ऑफ इम्पैक्ट, वेदर इट इज अ केस ऑफ सेंट्रल इम्पैक्ट or is it a case of oblique impact. The whole impulse during the deformation phase as well as the restitution phase occurs along the line of impact. So there is no impulse acting on particle A along the plane of contact, which is basically the plane or the axis which is being defined perpendicular to the line of impact. So किसी किस्म का चूंकि impulse y डायरेक्शन में या प्लेन ऑफ कॉन्टैक्ट के अलोंग एक्ट नहीं कर रहा, सो देयर शुडंट बी एनी चेंज इन द मोमेंटम ऑफ दिस पार्टिकल अलोंग द प्लेन ऑफ कॉन्टैक्ट। मसलन पार्टिकल ए की जब मैं फ्री बॉडी डायग्राम बनाता हूं, इंडिविजुअली मैं कंसीडर करता हूं, सो लेट अस कंसीडर पार्टिकल ए। पार्टिकल ए पे कोलिजन के दौरान पार्टिकल बी का जितना भी इंपल्स आएगा वो बेशक पीडीटी हो जो कि आपका डिफॉर्मेशन इंपल्स है, या आरडीटी हो जो कि रेस्टिट्यूशन इंपल्स है, ये सारा एक्ट करेगा अलोंग द लाइन ऑफ इम्पैक्ट। आप इस पार्टिकल ए के ऊपर अप्लाई करें प्रिंसिपल ऑफ इंपल्स एंड मोमेंटम। वो प्रिंसिपल क्या कहता है, वाई डायरेक्शन में आप ये प्रिंसिपल अप्लाई कर रहे हैं, सो वाई डायरेक्शन में क्या कोई इंपल्स एक्ट कर रहे हैं इन दोनों में से?
सर इसके में ये जो बॉडी बी है तो ये तो इसके दो कंपोनेंट्स होंगे, एक कंपोनेंट अलोंग द लाइन ऑफ इम्पैक्ट होगा, एक कंपोनेंट अलोंग द प्लेन होगा।
किसका?
सर ये जो बॉडी बी है
जी जी,
तो दोनों के एक्सिस के पे इम्पैक्ट नहीं डालेगा क्योंकि इसकी कंपोनेंट्स तो है ना सर अलोंग।
अभी मैं बता रहा हूं कि आपके पास जितना भी इम्पल्स आता है बॉडी बी का बॉडी ए पे या बॉडी ए का या बॉडी बी के ऊपर, वो सारे के सारा आएगा अलोंग द लाइन ऑफ इम्पैक्ट। ठीक है, ये जितना भी इंटरनल इंपल्स होगा इट इज गोइंग टू अकर अलोंग द लाइन ऑफ इम्पैक्ट, नॉट अलोंग द प्लेन ऑफ कॉन्टैक्ट या किसी एंगल पे एक्ट नहीं करेगा। दिस होल इम्पैक्ट इज गोइंग टू बी अलोंग द लाइन ऑफ इम्पैक्ट, दिस होल impulse is going to be along the line of impact. ठीक है, सो प्लेन ऑफ कॉन्टैक्ट के अलोंग जब कोई इंपल्स एक्ट ही नहीं कर रहा, सो अगर आप प्रिंसिपल ऑफ इंपल्स एंड मोमेंटम लगाएंगे जो कि कहता है एम ए वी आई प्लस समेशन एफ डी टी इक्वल टू एम ए वी एफ, दैट इज द इनिशियल momentum plus sum of all the impulses should be equal to final momentum. So once you are applying this principle of impulse and momentum on particle A along the plane of contact, this term is going to be equal to 0. So MAVI should be equal to MAVF for particle A as well as for particle B along the y-axis. Is this point clear now?
Yes, sir.
Okay, so whenever you are solving the problems of oblique impact, they are going to be solved using these 4 steps. Step number 1 में आप apply करेंगे conservation of momentum on a system along the line of impact. Step number 2 में आप apply करेंगे coefficient of restitution equation along the line of impact. Step number 3 और 4 में आप principle of impulse and momentum apply कर देंगे on individual particles along the plane of contact, from where you can find out the 4 unknowns. और जब आपको चारों कंपोनेंट्स मिल जाएंगे वेलोसिटी के, उससे आप ओवरऑल वेलोसिटीज के मैग्नीट्यूड्स और उनके डायरेक्शंस भी जो है वो डिटरमिन कर सकते हैं. Okay, so moving on to the numericals relevant to this topic of oblique impact. आज हम कोशिश करेंगे, हो सकता है एक एग्जांपल हम आज कर लें और बाकी दूसरी एग्जांपल और एक्सरसाइज के प्रॉब्लम्स जो है वो हम हो सकता है कल की क्लास में जो है वो सॉल्व करें. Okay, starting with example 15-11, in which you have 2 particles, which are these 2 disks A and B, having masses of 1 kg and 2 kg respectively. These 2 disks were traveling at the velocities shown. That is, velocity of A is 3 meters per second at an angle of 30 degrees with respect to the line of impact. Similarly, particle B was traveling with a speed of 1 meter per second at an angle of 45 degrees with respect to the line of impact before collision. These 2 particles collide together, and after collision, during collision, the coefficient of restitution is given to you as 0.75, and after collision, you need to find out what is going to be the final velocity of each disk, the components of x and y, components of each velocity after collision. ठीक है, तो सबसे पहली बात, ये सेंट्रल इम्पैक्ट है या ऑब्लिक इम्पैक्ट है?
Oblique.
Since both the particles were traveling at some angle with respect to the line of impact before collision, so this is a case of oblique impact. So if it is a case of oblique impact, we are going to solve it using the 4 steps of oblique impact. Step number 1 क्या कहता था कि आप सिस्टम के ऊपर अप्लाई करेंगे conservation of momentum principle along the line of impact. So let us take the line of impact to be positive side to be towards the right. So what is the momentum of particle A along the line of impact before collision? Can you identify it? The mass of particle A is 1 kg. The velocity component of particle A along the line of impact is 3 cos of 30. So the momentum is going to be 1 into 3 cos 30, isn't it?
Yes, sir.
Okay, what about the momentum of particle B along the line of impact before collision?
Negative.
Negative होगा. Okay, चले मैं positive sign यहाँ डालता हूँ. 2 into -1 cos of 45, isn't it?
Yes, sir.
So this was the momentum of the system just before collision. This should be equal to, as per the conservation of momentum principle, it should be equal to VA2 या VAX2 plus 2 VBX2. So this is my equation number 1. Clear है ये equation?
Yes, sir.
Okay, in step number 2, we are going to apply the conservation of momentum principle along the line of impact. So the conservation of momentum is already given for this problem to be equal to 0.75, and that value is going to be equal to VBX2 minus VAX2 divided by VAX1, which is 3 cos 30 minus VBX1 minus 1 cos of 45. So this is my equation number 2. अब अक्सर स्टूडेंट्स गलती क्या करते हैं, वो ये नेगेटिव साइन जो है वो भूल जाते हैं. ओरिजिनल फॉर्मूले में आपकी चूंकि रिलेटिव वेलोसिटी आ रही है तो नेगेटिव साइन बीच में आता है. सो एक नेगेटिव साइन वो हो गया और -1 cos 45 इनिशियल वेलोसिटी हो गई है पार्टिकल बी की अलोंग द लाइन ऑफ इम्पैक्ट। सो ये नेगेटिव नेगेटिव आपके पास पॉजिटिव हो जाएगा। सो यू हैव टू इक्वेशंस in terms of Vx2 and Vbx2. By solving these two equations simultaneously, you can get the value of Vax2 to be equal to Vx2 आपके पास आ जाएगा -1.26 meters per second. Similarly, Vbx2 would comes out to be 1.22 meters per second. This negative sign indicates कि particle A का जो component आएगा velocity का along the line of impact, that is going to be in this direction. Particle A का component जो है वो particle A का left side पे आएगा, particle B का right side पे आएगा. Are these two steps clear to all of you?
Yes, sir.
Okay, what about step number 3? What should be VAY2? Ji, anyone volunteer?
Movement along plane of contact.
हाँ, चूंकि plane of contact के along कोई impulse act नहीं कर रही, it means that there shouldn't be any change in its momentum along the plane of contact. That is, MAVAY2 should be equal to MAVAY1, or in other words, VAY2 should be equal to VAY1, which is 3 sine of 30 degrees. ठीक है? Similarly, step number 4 में क्या करेंगे? Since there is no impulse acting on particle B along the plane of contact, so again there shouldn't be any change in particles B's momentum along the plane of contact. That is, VBY2 should be equal to VBY1, and that is going to be equal to -1 sine of 45. So इसका momentum positive आया, इसका momentum negative आया. So in which quadrant VA2 would lie? जी, any volunteer जो कि बता सके VA2 यानी velocity of particle after collision किस quadrant में lie करेगी? सेकेंड क्वाड्रेंट, बिकॉज आपके पास VAX2 भी नेगेटिव आया था, आपके पास VAY2 भी जो है वो पॉजिटिव आया है. सो नेगेटिव पॉजिटिव मींस कि आपके पास ये VA2 होगा. इसी तरह अगर मैं पार्टिकल B की देखूं, X पॉजिटिव और Y इसका नेगेटिव. X पॉजिटिव Y नेगेटिव मींस कौन सा क्वाड्रेंट होता है ये? चौथा क्वाड्रेंट. इट मींस के पार्टिकल B जो है it is going to have velocity VB2 in the fourth quadrant, whereas VA2 is going to be in the second quadrant. तो ये दोनों particles इस डायरेक्शन में rebound होके जो है वो move करेंगे. Now can you determine the value of VA2 and VB2? क्या आप determine कर सकते हैं वो क्या values होंगी VA2 और VB2 की?
सर मैग्नीट्यूड ले लेंगे मॉडुलस.
बिल्कुल, दोनों के स्क्वायर करके सम करके अंडर रूट ले लेंगे दोनों कंपोनेंट्स का, तो यू विल गेट VA2 as well as VB2. Similarly, you can find out phi2 as well as theta2. कर लेंगे फाइंड?
जी सर कर लेंगे.
Okay, so we are going to stop at this point.